Okay, the penultimate chapter is all about handling errors. Again, this isn't really on the GCSE specification, other than there is a section called robust code, which is what we're going to be talking about today, a way of reducing program crashes. And every now and then there is a question on the GCSE about this. You won't have to regurgitate the code, you'll just have to talk about maybe how you can handle errors, what types of errors there are, how you could mitigate those errors. But we'll cover it anyway because it doesn't take very long. First of all, open up in the sample code the program called break me. What I'd like you to do is try and break it. Try and give it input that it doesn't want and see if you can make the program crash. By the way, closing the window down doesn't count. Have a go at that. So here is the break me program. Hopefully you had a go at that. So there's a number of techniques in here about checking ranges, whether values are blank, whether they are the correct values like alphabet characters, and also handling some exceptions. And really that's what we want to talk about. So we want to handle errors through robust code. Now think about robust as bust. You're trying to make the code so that the user can't bust it, can't break it, can't cause it to crash. Now in computer science we'd call those unexpected actions or terminations handling by coding techniques. And there's some errors that are so common they actually have their own commands to handle the errors for them. There's a couple there we've just shown you example, name errors and file not found errors, which we'll go into a little more detail later. So the whole thing's called exception handling. Basically, we're stopping the program from crashing. How does that look in Python? We use what's called the try except statement, and this is pretty standard through a number of programming languages. First of all, you have the word try with a colon, then indented in there is all the risky code that you're going to use. And should there be a problem with that, then what you do is you use an except. In the except, you then handle the kind of exception you're looking for, the type of exception here, and then finish off with a colon. Indented in there is the code that will execute if there was a problem with the risky code. And that's your clause, because after that the program just continues as normal from the indent that lines up with the try except clause, and off it goes from there. Let's look at some of the exception handlers that you can use. Value error. Well, a value is really, it's not the data type, it's more that can a particular operation be carried out on that data. For example, when you're trying to cast or convert something like a string to an integer, it's got to be possible. So the string dog will not convert into an integer, but the string 3019 would convert into an integer. So that's what you're checking, that's what you're trying to handle. Have a go at 14.6 value errors. Have a go at that. Here it is here. What we're doing here, we've got some lines of code. We've got a while loop here. It's going to run forever unless we break out of it. And in here is a try except statement. We've got some risky code. And if there's a problem with that risky code, then this code will execute. And then we're just doing a call. So prediction, what do you think will happen when you run that? Then run it, see what you think will happen. Then run it a few times and try different inputs. Try dog, 3.25, 3, -3, anything else, like a blank. And then see if you can change it to see if it'd work for floats. It's not a great change because you'll notice that you can actually put a whole number in there and it will still accept it. But just see if you can change it as a little example of how you can deal with floats. Pause it and I'll give you the answer in a second. And here's how I would have done it. Keep it largely the same, just maybe change the docstring at the top to talk about floats rather than integers. Main difference here is you're casting to a float at this point rather than to an int. And then I've just changed the input message to make a bit more sense. Nothing changes there, or there, or there. And I've made the output message for in case an error actually happens to, again, make sense. That's about the only changes you need to make. But as you see, if you run it, if you type in a whole number of 3, it will still be able to convert it to a float. It will just come out as 3.0. But as an exercise in modifying that, hopefully that's good enough. Next kind of error is a zero division error. Basically, if you divide something by 0, it's going to cause you a problem. So here's an example here. You've got a subroutine, and it looks like a procedure because I don't see anything returning, called divide nums. A little docstring telling you what it's doing, and then your try and your except. So your try here, the risky code is it's taking some input, converting it to an integer. Then we're also taking another integer, well, another string, and then converting it to an integer. And then we're going to divide those together right here, where x divided by y. Now, if there's a problem, if you try and divide by 0, the handler, the except here, should handle that, and it should give you a cannot divide by 0. Then it sets y to 1. If you look at the example here, you try and 15 divided by 3, it's going to give you 5.0, no problem at all. The except won't get triggered. But If you try again with 15 and this time divide by 0, this time it does tell you they cannot divide by 0, so you can see that your except here was triggered. Another kind of error is a file error or an I/O error. This is when you're trying to reference a file object and it doesn't exist, or where you're trying to put the file object and trying to write to it, the area itself is full. At GCSE though, you shouldn't have to worry about that. You only need to really worry about being able to find the file if you need to open it. And you'll find normally when you write to files, even if the file's not there, it will just create the file for you. So this really is only for a read. Here's an example. So we're reading the file, docstring, and we've got again a try and accept. In the try, we've got the normal file handling. So we're doing a read switch here, opening a file called shopping.txt, creating a modifile object to address that, then reading in a line, and then while there is lines to read, just keep on printing them out and then go to the next line and carry on until you run out. Now, if you tried to open up shopping.txt and it hadn't existed, then the accept would have triggered here, and you'll see it says print file does not exist, and you can see here that shopping.txt in this example does not exist. Another example is a keyboard interrupt error. This is where you're trying to break out your program by using a keyboard command like Control-C, Control-Y. Some keyboards, Del, will cause a problem. This one, we've got a while true, and in that while true, we're just doing the try except. So the risky code here is you're printing something, and you're saying, okay, get me some input, turn it to lowercase, save it as stop, or store it as stop, and if that thing they just typed in, if that variable they just typed in is the same as stop, break out of the loop. Now, if they then try and use a keyboard interrupt at any point, that's when this will trigger, and it'll just say you can't use the keyboard to stop me. It'll look a bit like that. So please tell me to stop. No, so it'll ignore that. Carry on. Go right back up to the true again. Again, print please tell me to stop. If you try to push Control-C at this point, it will then trigger the accept and say you can't use the keyboard to stop me, and then go back up to here and carry on with the while loop. So print please tell me to stop, then you can type stop. Use the dot lower just in case you got your cases wrong. We can just check that way for lowercase stop, no matter if they typed caps or not caps. We can also handle multiple exceptions. In the accept statement, you can put multiple errors that you're checking for. This is just a part of that code. So you see here we've got options in a list 1, 2, 3, 4, or an array. You print out the menu options themselves. So remember your \n is a new line, your \t is a tab, so it'll just print out here 1 enter name, 2 read rules, 3 play, 4 exit, all on new lines and tabbed in. It sets a variable to menu choice to 0, and it says while menu choice is not in options, so while, which at the moment menu choice, which is 0, is not in options, well, while 0 is not in the options, 1, 2, 3, 4, which it's not, it will keep doing this loop. So we've got some risky code here, and in this try, what it's doing is trying to make sure you've put in an integer. Menu choice is the variable, you're assigning some input. In this case, it's just saying you 1, 2, 3, 4, but at this point you could type in 5 if you wanted to, it doesn't matter, as long as you can convert it to an integer. If you can't, the accept with the value error will trigger, and it will say you must enter 1, 2, 3, 4, and fire you back up to the while loop again, and off you go again. If you try to Control-C or interrupt at any point in this process here, it will handle that, tell you you entered an invalid character, and fire you back up to the while loop again, and off you go again. But as long as you type in something which can be an integer, then great, it's happy enough. It will break out of that. The print there is a little bit superfluous, not really needed, because you're going to break out of the loop once you get an integer. But as an example, it's fine. Okay, over to you. Try exercise 1411, or as in your sample code as 14-11 exercise. Try those 3 tasks. Here it is here. So question 1, setting a variable, assigning it number 1, and then while that number is less than 13, you're going to do this format command with a little bit of calculation. First of all, there's a problem with that, what kind of error that is, and that's from chapter 13, those kind of errors. Question 2, can you correct that code above so that it actually prints out the squares of 1 to 12? And question 3, see that code there below, the read file code? Shopping.txt does not exist, so it's going to crash. Can you fix that? And you should be able to use a previous slide to help you with that. Pause it, have a go, and I'll show the answer in a bit. Okay, here's what I did. I just incremented the number for question 1. Number plus equal 1, so that's the same as number is the same as number plus 1. You could have done it another way, so you could have used a for loop, completely changed the while loop and done it that way. But up to you which way you do that, as long as you fix that. So what type of error is that? Well, it's a logical or a runtime really, because it's not a syntax, it's following the rules. When you run it, there's a problem with the thought process because you're not incrementing the number, so it's running forever. But you could also argue, well, That now stops the execution of your program from now on. So really, isn't that a runtime error because you can't continue with your code? Up to you to argue that. Question 3, how we did that is put the risky stuff in a try. This part here is how you read a file. We just put a try around that, and if there's a problem with that, for example opening shopping duck text, put an except on it, and it'll just say the file does not exist. All this boils down to this chapter and the last chapter, and the chapter before that, validation, types of errors, exception handling. This is the whole idea about stopping somebody from breaking your program. It's known as defensive programming. And that goal is really make your code as robust as possible, make it reliable as well, make sure the program code can run as long as possible before somebody breaks it. In your sample code is one called defensiveprograms.py. Open that up. There's quite a few things to do in there. If you get stuck, use defensive programs with hints. Here it is here. So you can see quite a lot to do. You've got a lookup check, which we didn't really talk about in the validation exercise, but it's when you have a list of things you want to look up and you only want those particular items. As a lookup check, you're trying to constrain their inputs to only show the list of choices you want them to make. So that one can extend that to have a choice of D and be able to allow that. Next one is the type check. Is the data type correct? So if you try and convert this input into an integer, can you stop it from crashing if somebody put in, for example, the words TWO2? Then using that code again, can you then set a range check, get it within a certain range? Can it reject any number less than 1 or more than 10? One here for what we learned today, which is a try except value error. So very similar to the one with a type check, but this time it's a value check. You're just saying if they type in 2, can you handle if it tries to convert that to an int and cannot? Length check as well is if you enter 1, 2, 3, 4, 5, 6, 7, 9, 0 and they want a 16 digit, can you reject that number if it's not 16 digits long? Presence checks. We didn't really talk too much about this in chapter 12 either, the validation. The specification wants you to also know about whether there's actually presence of input that you want or presence of a value. So you really want to check if it's empty or not. To do that, you use the len function. Now what goes with validation, or one of the techniques you need to know is validation, but also authorization. This is where you want to authorize something, allow something to be able to do something. So we've got a lot of somethings in there, but for example, allowing a user to access resources, allowing a login to access a system, and combining that with a format check is the right kind of format that you're looking for. Right, so as I've said here, this code here is how you'd never want to do it. You'd never want to hard code usernames and passwords. I mean, no way would you want to do that. You'd have some kind of encrypted database that you'd look these up. You wouldn't type in passwords and usernames in the clear, as in like anybody looking over your shoulder can see what you're typing. But for GCSE, you just need to know the theory and be able to write these kind of routines. Use a number of nested ifs. Get your input. First check is to see if the username is correct. If it's not correct, you come down here and say it's an incorrect username. That's the if else. If it is correct, great, you're here now. You can then do a password. If that password is correct, you get to do this. You get to break out of your loop. If it's not, though, it'll tell you it's the wrong password. And if any of those are wrong, any of these else gets tripped, you're up here. So you can only really get the username correct, the password correct before you get into here and the break. So what you want to do with this one is change that code to only allow usernames with the first 2 characters as letters, followed by exactly 6 digits. There's some kind of length check required there. All of the formats should be rejected. Then stop them, be able to keyboard interrupt that whole process. So add a try except round some of that code to stop it. Have a go at that, pause this, and I'll show you the answers in a little bit. Here are the answers. First one, the lookup check. If you wanted to add D, just put it into the options. Simple as that. Number 2, the type check. Get your input and then check that input. Now, that number they put in, is it a digit? If it is, great, do all this. If not, your else kicks in, not a number. Assuming it is, you can do the conversion to an integer and then check. So that number, is it less than 1 or is the number more than 10? If it is, well, it's out of your range, and that's that clause there. Otherwise, great, you've got everything you wanted. Print out, you entered, followed by the number. For the value error, what we did today, get your input, put the risky code in a try. So you see this, are you allowed to do that? Can you convert what they just typed in to an integer? If not, you accept value error will trigger and the error message of could not convert to integers will be printed. Otherwise, it was okay. You can print you entered num1. Length check. get your credit card, and then check if the length of that credit card is 16. Now, what we've not done here, we haven't converted it to digits, we haven't checked if there is digits and that kind of idea, but I suppose what we might want to do, if we wanted a credit card number, is do the len check and then follow by and credit card dot is digit, and that means you'd have digits and a length of 16. You could enter the credit card, and if you wanted to as well, you could convert to integer if you wanted at that point. Next one was your presence check. Get them to type in the word, and then just check. See the length of that word they just typed in? Is it 0? If it is, well, it's empty, and that's your presence check. That means you needed something. Otherwise, you can print out the word with some text saying you entered whatever it was. Now, the authorization one looks a little bit scary because of the sheer number of nested ifs. Look, 1, 2, 3, 4 nested ifs, and the corresponding else's with each one. But this is why you indent things, to make it easier to see what if matches up with what else. So how we did this, get the username, put all of this in a while true. So we need to break out at some point, and we're only ever going to break out when, at one point, which is when we've got a correct username and a correct password. So get them to type in a username. First check, see the length of that username, is it 8? Because if it is 8, then we know we've got part of the format working. We don't know what's in that 8 characters, but that's why the next line we check. Now, if it wasn't, that's why you're saying it's not the correct length. Let's assume it is 8 characters. This is where this check is coming in now. If the username from the beginning up to index position 2, but doesn't include, so that would be username character 0, character 1, which is the first and second characters, are they alphabetic? If they are alphabetic, great, that's the first clause correct. But with an and, both things need to be correct. So we're also checking this as well now. From character index position 2 onwards, are they digits? So that's basically your characters, your 3rd, 4th, 5th, 6th, 7th and 8th characters, are they digits? If that's correct, great. You're now into the next phase. But if not, that's where you say, hang on, that's the wrong format. Assuming that was okay, you then check the username they typed in, is it this particular username? And if it is, great. You can then go and get a password. If not, you can just tell them it's an incorrect username. Once you got the password, check it. Is it one you want? If it's not, wrong password. That's the else clause. But if it is, great. You're right in the very center of the whole of this routine, which says access granted, and you break right out of the loop. Boom, out to here. There you go. So, quick recap. What did we do today? Well, we learned about exception handling, how to reduce errors, how to make your code more robust, stop it crashing, certain errors you looked into, handling files, handling keyboard interrupts, how to combine all these things. We also looked at some of the validation techniques from Chapter 12, and we also looked at authorization, which is a way of getting access to resources. Part of the GCSE requires you to be able to write simple authorization routines, so if you didn't get that, practice on that. As usual, if you've got problems with any of this, you know how to get in contact with me. Drop me a line. Cheers.